Happy Tuesday, happy last day that you get to have Mr. Vance, and I'm back tomorrow. You'll be stuck with me again. So our last lesson on videotape. So first thing I'm gonna do is go over your homework. So the first part, polar bonds. If something is polar, that means it has an unequal sharing. Polar means it has those positive and negative ends. Whereas non-polar, not poles, so there isn't a positive and negative end, so that is an equal sharing. Okay, so polar has poles, they're not sharing equally. Non-polar is equal. All right, so now we're going to look at the different molecules, figure out if they have a positive and a negative end as far as their bonds, and then we're going to look at some of their symmetry and stuff. Okay, so first thing I notice right away is we have an oxygen bonded to an oxygen. They're both equally as attractive for those electrons, so this is going to be nonpolar. And same thing with this one, with our diatomic one. That's a nonpolar bond between them. And then because it's nice and symmetrical, you have an oxygen on each side, they're also nonpolar molecules. Okay. All right, then I come up here. We have hydrogen and bromine. Bromine has a greater attraction for the electrons, so the electrons are going to be pulled this way. So bromine's going to be a little bit negative, hydrogen's going to be a little bit positive. So we have a polar bond and a polar molecule because we have hydrogen on one side, bromine on the other. So it's not symmetrical. All right, then let's go ahead and look down here. So the oxygen has the highest electronegativity of all, the highest attraction. So all of these electrons are going to be pulled up this way. So this is going to be our little bit of a negative end, a little bit of a positive end. This would be, hydrogen is kind of like its feet, and then this oxygen is like making it lopsided. So this is going to be polar bonds, and then that's also a polar molecule. And then the top one, you have to imagine that it's three-dimensional, like what you did on the computer. So this is a top and a bottom, and these three are actually circling around the center, making kind of like a peace sign. So it's not really that two are on one side and one is on the other. Okay. All right, so between the phosphorus and the chlorine is more attractive, so the electrons are going to be pulled out a little bit. So each of these bonds, these are going to be a little bit negative ends, and then this is going to be a little bit positive in the center. But since we have phosphorus in the middle, chlorine on top and bottom, around the sides, the negatives are all around it, not one end or the other. These are polar bonds between them, 2.2 and 3.2, but the molecule itself is nonpolar. All right, then the multiple choice. So polar substances mix and dissolve in polar. So polar dissolves polar. Non-polar mix and dissolve non-polar. So which of the following best describes this? That's the phenomena of likes dissolve likes. So non-polar with non-polar, polar with polar. Like dissolves like. A pair of jeans has an ink stain. The inks are known to be non-polar. So if you want to remove the stain, you're going to have a non-polar solution because likes dissolve likes. And then which of the following best describes water? So water has this bent shape because it's a tetrahedral that's missing two of its pieces. So it's bent. And then if I taught you nothing else, water is polar because it has these unshared pairs. That makes it polar. All right, so then the next set of questions is whether or not something would dissolve in it. So will ethane dissolve in water? So we know water is polar. Ethane is symmetrical, no unshared pairs, so ethane is nonpolar, so no, it would not dissolve. Ethanol, we have this lopsided, unshared part, we have this non-symmetrical, so ethanol is polar, so polar and polar, so yes, ethanol would dissolve in water. All right, back side. Will methane dissolve in water? So again, we know Water is polar. This is nice and symmetrical, no unshared pairs, so it's nonpolar. So since they're not the same, no. Methanol, kind of the same thing as we saw with the ethanol. We have this out here that makes it not symmetrical. So this is polar. We know water is polar. So since they're the same, yes, methanol would dissolve in water. Will isopropyl alcohol dissolve in water? So we know that water is polar. We have this unusual group here that doesn't belong, so that's polar, so yes. Propane, water is polar. Nice and symmetrical, no weird groups that don't belong, nothing unshared. So this is nonpolar, so no, it would not dissolve. Will water dissolve in hexane? So we know water is polar. If we look at hexane, no unshared pairs, no unusual groups sticking off it that makes it offset. So hexane is nonpolar, so no. And then last, would oil that's nonpolar dissolve in hexane? So we know hexane is nonpolar. They're telling us oil is nonpolar, so yes, because likes dissolve likes. All right, water is essential for Earth. Is water polar or nonpolar? Water is polar. It's a bent polar. Acetic acid is polar. Will acetic acid dissolve in water? Acetic acid is polar. Water is polar, so yes. Substance A is polar. Substance B is nonpolar. Will A dissolve in B? No. They need to be the same. Substance C is nonpolar. Substance D is nonpolar. Will they dissolve? Yes, because they are the same. Okay, so make sure you check and go over all of your homework.